Aviatrix and our great partner in the Netherlands, CloudNation. Today, we're going to be covering some of the coming changes within Azure specifically. Specifically, are we covered with egress security controls, right? There's some big changes coming up, and we want to make sure that our customers, our friends, our partners are prepared for that. To talk about this, we have a great lineup today. Myself, Dan Sheldon, I'm the Director of Solutions Engineering for our EMEA team. And with me, I've got Frey Kademi. Frey?
Yep, good morning, everybody. My name is Frey Kademi, and I'm running the partner management here in EMEA, in the EMEA region, based in Germany. Been on board for 5 years. So great that you're all joining today.
Perfect. Thank you, Frey. And in our CloudNation team, we have two amazing co-presenters today. We've got Don and Mark. Don, you want to give a quick intro?
Yeah, sure. Thanks, Dan. And thanks to Aviatrix for organizing this webinar with us. Unfortunately, our colleague Martijn, who was supposed to do this talk, got ill this week, so I'm taking his place instead. A little bit about CloudNation. We were founded in 2018. We're based in the Netherlands. We perform consultancy projects and managed services for almost everything public cloud related, with a focus on Azure and AWS. And we have multiple specializations, of which networking and connectivity is one. So that's why we want to highlight this topic of today.
Perfect. And Don?
For the half of my time, I'm team manager for... please, Don, continue.
Yeah, Daan Toes, a cloud consultant at CloudNation. I've been in Azure for 5 years now, just 2.5 years at CloudNation at the moment. So I do a lot of cloud consultancy and engineering as well. So I've done a lot of terraforming and deployments to Azure, doing hub spoke topology and those kinds of things. And Mark, what about you?
Half of my time, I'm team manager from one of our AWS teams, and for the other half, I do projects for customers. Some together with Dan on Azure, and because it's connectivity related, I work on both clouds.
Perfect. Thank you, gentlemen, very much. And I think that covers about us for the most part. I think Frey and I both, step with about 20 years experience in network and security engineering as well. And then I think, 5+ in the cloud at this point, which is across multiple clouds, AWS, Azure, GCP, OCI, Alibaba, all the big five, I would say, less some of the other ones. Cool. Let's get to the meat and bones of it. So I'm gonna hand it over to Don. I think Don, we can talk a little bit about what's coming up in September. What are the changes? How are they going to impact our customers? How do we relieve those problems?
I'm gonna cover this first slide. The why. Yeah. What are we talking about today? Well, Microsoft made an announcement a couple of months ago that after September 30th of this year, new virtual machines will not have default outbound internet access. So currently, if you deploy a new virtual machine, it will automatically have explicit internet access for everything that it needs to be able to connect to. But like I said, after September of this year, that's not available anymore. So you'll have to take some measures yourself. Like I said, I also work with AWS for some of our customers, and this is the way AWS has been doing this for at least the past 10 years, as far as I know. And in my opinion, it's a really good idea to be able to isolate workloads from the internet and allow egress access intentionally, so that you only if you really want them to access the internet that they're able to, and you take the measures and deploy the resources for that. So what are the risks when customers do not do anything before this measure is being implemented? Well, future virtual machine deployments will not work for downloading software or updates or accessing external resources like SaaS, for example. Unless you have extended support, then this is still possible. But so this is a potential interruption for business processes or security risks. And also, it's not recommended to open a virtual network to the internet by default if you're following the Zero Trust Network Security Principle, which is adhered to by a lot of companies nowadays. So therefore, it's recommended to have explicit methods of connectivity instead of implicit when granting access to resources within your virtual network. Also, customers do not own the default outbound access IP address, the public IP address that these virtual machines are using until now. So this IP address might change, and any dependency on it could cause issues in the future. If you're, for example, relying on whitelisting public IPs by a third party, it's much better to have a fixed public IP to a central resource. And yeah, of course, Dan will now provide a couple of examples you can implement to assure that.
Yes, thank you, Mark. So all Azure customers get an email from Microsoft that they are doing this from September. And basically they are saying you have 3 native Azure solution options. And those are these 3. We have 5 in total, so these are the first 3. The first one is basically saying you can have a public IP on your virtual machine. This is not recommended, by the way, because this is not best practice. And security-wise, you don't want to do this, especially in your production workloads. Maybe you can do this in a sandbox environment for testing or that kind of stuff, but this is not recommended. The second method is using a load balancer. So you can use a load balancer in front of your virtual machines, and then those virtual machines can use that public IP to go outbound to the internet. This does have some caveats because you need to do port allocation upfront. So this does not scale dynamically. And of course, since this is also a public IP, this does not have any security measures on that public IP. So if you have a production workload or a large environment, I would not recommend the load balancer option either. Also, it's more complex to set up. The next method is the NAP gateway. Microsoft is saying that this is their recommended solution for now. If you don't have any security in mind. So I will go in the next slides about more security-wise, but the NAT gateway is an easy solution. It's simple to deploy. You deploy it on one NAT gateway can support up to 500 subnets, and all those subnets can use the NAT gateway public IP to go outbound. So it's not for inbound traffic at all. It's only for outbound, and that's the optimal outbound solution. It's also easy for outbound scaling. So not like your load balancer, you don't have to do port allocation upfront. It does that dynamically for you. But still, this is not a very secure way of deploying your resource in Azure. So to do it more securely, we recommend to do a Azure firewall. So this is also from Azure best practice to use a hub-spoke topology. So in your hub, you will have your Azure firewall, and all your spokes, VNets and subnets will have a route table that will route all traffic from the spoke to the Azure firewall. And then the Azure firewall, you can do your traffic rules and say, okay, this spoke can go out to the internet or not, of course. So you have more security, but this also comes with more costs. So an Azure firewall, it depends, of course, what kind of SKU you use. They have a basic SKU, standard SKU, and a premium. And all the SKUs have different features, of course. But the basic one is like 300 per month, and the premium one is about 1,300 a month. But that does come, of course, with additional security measures like threat intelligence with deny mode, TLS inspection, that kind of stuff. So it's more costly, but you also get more security. One problem might be for larger enterprises is that the Azure firewall has fewer snub ports available. That means that per public IP on your Azure firewall, you can have 2,500 ports available for your outbound traffic. So if you have more than 2,500 VMs potentially that want to go outbound at the same time, you're gonna have port exhaustion. There is a simple method to increase the public IPs on your firewall. So there's a maximum of 250, and that will have a total of around 600,000 snap ports. But still, this can be a limitation for some customers. And that's why there is a fifth option that we can implement an Azure firewall with a NAT gateway. That means that we get the capabilities of the NAT gateway, which can have up to, I think, 16 public IPs per NAT gateway. But every public IP can have 64,000 snap ports, which means in total you can have over 1 million ports available for your outbound traffic. So this way it's more secure, it's more scalable, and for larger enterprises, this is our recommended option. Of course, with an Azure firewall and a NAT gateway, the price does increase, but you also get a lot of security features available, and of course more snap ports available to you. So to summarize all the Azure native solution, we created a table, and Mark is going to cover the summary of that table for us.
Yes, well, thanks, Dan. I think some good insights. Well, of course, we would like to assist customers in making the best decision. And for that, we made this overview. It doesn't cover all the aspects, but in our opinion, the most important aspects. These are all the Azure native options that they offer. And this provides, I think, a clear overview between the main differences. Choosing the best scenario for you and your organization depends on many factors, like the size of your cloud environment and the amount of virtual machines you have. For example, the SNAT ports available that Dan mentioned in the differences between the scenarios, the amount of egress traffic that you're expecting for both the scalability that is required, but also the cost aspect, because a couple of these services have a data transfer cost component, the criticality of these workloads, but of course, besides these native options, there are also custom solutions available, like Aviatrix, which can add even more advantages. And Frey and Dan will explain those in the next section.
All right, yeah. So I think I'll take over the next slide here. So let's quickly introduce Aviatrix. Aviatrix, what we've built is we've built basically, it's almost like a cloud SDN. So you deploy with Aviatrix a centralized controller. The controller runs in your accounts, or we also have a SaaS option for this controller. And using this control plane here, we can deploy a drop-in replacement for the NAT gateways. Okay, so if you think about a NAT gateway deployment, which was introduced in one of the previous slides, the NAT gateway deployment is great because it achieves your what you need to do, which is get internet access from a private subnet. The issues with a NAT gateway, though, is there's zero security and zero visibility, and you pay a lot of money for it. So the drop-in replacement for the NAT gateway is this controller. It can deploy the Aviatrix NAT gateways, which provide built-in security, built-in visibility. It's also multi-cloud, which is great. Right now, this webinar, it's purely about Azure, but many companies, they're either thinking about multi-cloud or they are multi-cloud. So it's good to have one common solution across the hyperscalers. And the beauty also about this solution is you really have now a distributed perimeter. What does that mean? That means you're not relying on one central security device to provide security across your entire cloud. Because if you think about it as well, all of your cloud workloads, they're always one hop away from the internet. So rather than getting security in a central place, you can provide security one hop away from the workload itself. Okay, and I'll just go over to the next slide here. And so some of the things that are included here in this drop-in replacement for the NAT gateway is we provide you observability, so you see exactly where your workloads are going into the internet. Okay, so you see which FQDN they're talking to, which ports, which protocols, how much data is sent, which FQDNs they're talking to. We provide governance using this deployment here as well. Governance meaning you can also apply security rules. You can do forensics. If there is like a malicious actor on the network, you can find out which internet destination that was talking to over the past 7 days, which ports, protocols, and so on. Security, so you can provide a zero trust approach with this NAT gateway deployment, meaning you can create a deny all rule with just explicit allows. So you can really create a zero trust egress deployment using this drop-in replacement. The solution scales. It's a distributed deployment. Distributed systems, they scale the best, much better than centralized solutions. And then the last point here is the cost. So actually what we see is when we replace the cloud native NAT gateways at customer environments or the cloud native network firewalls, we actually introduce lots of cost savings. So on average, we see about 25% cost savings, which is a super interesting one. Why pay so much money for zero security and zero visibility? And now I'm going to hand it over to Dan.
Thank you so much, Ray. Yeah, to that point, just talking about it from an AWS perspective, right? Azure is very much the same, but all of the components that go into what that solution, what Aviatrix provides for our customers, there are a lot of point solutions that have to happen from cloud native perspective in order to supply that, right? So everything from logging analysis, VPC traffic mirroring, guard duty, DNS firewall, network ACLs, AWS firewall, and NAT gateway. Again, this is a AWS specific view, but it's almost identical in Azure. So in order to do all of the things that you're getting just from that single box, from that single platform, you would have to have a lot of the cloud solutions, point solutions, not to mention the way that these charge. So generally, let's just talk about NAT gateway, for instance. There are 3 charges that you get for every NAT gateway that you deploy. You get the initial charge for just having that service on. So every hour it charges you, I think 4 cents per hour. And then every gig of processing charge, which is effectively every gigabit of throughput that's being natted, will get that charge. And then every gig of throughput that's egressing your cloud account will also add an additional charge. So all of those kind of line up. Again, 2 of the 3 of those you won't pay with Aviatrix. We don't charge for any throughput. We don't charge for having the service on, anything like that. Unfortunately, you still pay the egress charge. If we have figure out a way to ever get rid of that, you guys will be the first to know, because I think the entire industry would like to hear about that one. So how does it work virtual versus a centralized firewall? So generally, when you are utilizing a centralized firewall or centralized NAT, you have to pay those inter-VNet or inter-VPC charges. So that's a charge right there. And then again, if you're utilizing Palo, Fortinet, Checkpoint, one of those, they are great solutions, but they're very costly. So you're not only dealing with the EC2 instances or the VM instances that they're spun up on, you're also paying for the licensing charges, and they have a pretty CPU intensive workload. So the throughput limitations are significant. Getting rid of those by actually doing all of your enforcement directly in the application workload itself, and then has access directly out to the internet with maintaining that security, that governance, the inspection, the observability, all the components that Frey talked us through. Not to mention the fact that you don't have to manage multiple individual clusters for different directionality of travel. You can just manage it all from a single centralized control plane. No individual maintenance, monitoring, or management that you have to do for the solution. So again, it doesn't have to be in Azure. This is going to be a new issue for our Azure customers starting in September, but this has been the same case in AWS for years, similarly in GCP. What are the benefits within every single VNet? Simplified routing, you've got a single, you can have a single management plane for any of your protected islands. So if you have VNets that are not communicating to any type of centralized hub, they're not connecting to a firewall right now, all they need to do is have a workload, and that workload needs internet connectivity in order to get to Linux updates or all the kind of the components, any other SaaS offerings that you're utilizing. You can protect those with a Aviatrix spoke gateway in that VNet without any additional management complexity, things like that. It's all still centralized. Or if you need to actually route into other AZs, into other VNets, obviously that's something very simply done. Or even if you have to access things through a centralized security VNet, we can assist with that as well. So lots of solutions under one cover. We talk a lot about how do we manage that? How do we make that easy to deploy? We have two options for our customers. So we have a self-managed controller. This really is the controller and UI device lives in your environment under your administrative control. If you have multiple cloud environments, AWS, Azure, GCP, it can spin up in any one of those. You don't have to spin up one per cloud provider. You can have just a controller in Azure, and that's providing your total global multi-cloud environment management. Or we have a managed service, right? So Aviatrix owns the sizing deployment lifecycle. It's basically as a service. So your controllers will dial out to the controller, and you can do all of your management there. Think of it very similar to like a Meraki solution. You guys all know it, and some of you love it. The other half of you love to do it self-managed. So let's give you the choice, right? So that's really what it looks like. To update Mark and Don's table earlier, same deal. We just got rid of, we added one option for you, which is, again, Aviatrix Cloud Firewall allows us significant outbound scaling. So we can scale out to thousands of individual VNets or VPCs. Some of our largest customers are 6,000, 7,000, 8,000, somewhere around there in total VPCs and VNet count. The security is very, very strong. Again, FQDN-based security, URL-based security, a lot of additional observability on top of that. So, how much total throughput's going through it, things like that. The simplicity couldn't be any more simple, right? It's as simple as spinning up the VM instance that is that spoke gateway, enabling natting so that traffic is actually going through it, and then you can enable any policy that you want to do. Right? It's as simple as that. It literally takes maybe 5 minutes. And then cost is significantly low because we talked about those different, components that go into the cost for the Azure native solutions. We don't have those. So the best use case is for scale, feature richness, and multi-cloud environments because it's identical regardless which cloud you're deploying this in. So same way that AWS is requiring that gateway for default outbound egress from local VPCs. You don't need those. You don't need a NAT gateway with an Aviatrix solution. You could replace that. Same thing for Azure, same thing for GCP, OCI, Alibaba Cloud, et cetera. So have one centralized homogeneous environment that's doing all of your egress filtering controls globally from a single centralized policy, right? So can't say that much more than that. I couldn't find out the total number of SNAP ports. I'm just full transparency. So it's not a constraint on our part, which is I'll get you the number after the fact. But I know we have a couple questions that are coming in. I wanted to get to those real quickly. So I'll ask this to the team. I think probably Frey, you're the best to answer this one. For inbound traffic in Azure from outside, from Aviatrix support, what would you say is the best? What's the recommended approach from Aviatrix? And we can open that up to CloudNation as well.
So there's different design patterns that we have for inbound. So for ingress traffic flows, typically So the most common is I create some sort of kind of DMZ VNet or something like that, where I track all the ingress traffic. I can do it in the hub as well. So that means the traffic comes in a central point where you have like a load balancer, a WAF. Depends on what kind of traffic it is. Maybe you want to have some sort of CDN like Azure Front Door or something like that. And then once, before it goes on to the destination, so the destination would sit within a VNet. So the most typical ingress that we see at our customers is doing a centralized ingress as opposed to a distributed, just because you want to make sure that you do the necessary inspection, whether it's going through a WAF, whether it's going through a next generation firewall, or using a service like Front Door from Microsoft. So that's one design pattern, but typically we integrate with the native for those ones, like using app gateways, for example. Yeah, I hope that answered your question.
Yeah.
CloudNation, do you guys want to add anything to that one?
I can elaborate a little bit. With the native services, it's for large part the same, of course. It really depends on the type of traffic that your it's application gateway. That's the best resource for that. With a WAF also combined, of course. If it's other type of traffic, then a public standard load balancer is the best solution. And then, just like Frey said, we often implement Azure Firewall after that. After the application gateway or the load balancer to points. Yeah, and indeed, if you need additional visibility, for example, added value instead of the native services.
Perfect. Thank you, Mark. Thank you for the questions, Rob. That was a good one. What are the differences in implementation timelines between the options? Does Aviatrix take longer than the native solution? So I'll actually open that up to Don first. So we talk about the different options, I think somewhere around here.
Yeah.
Any specific points about implementation timeline for these? Thank you for the question, Alex.
So yeah, implementation for just a public IP is easy. That's not so complex. Load balancer is a bit more complex, but still pretty easy. Same as the NAT gateway. I think that's just one resource, and then you connect it to your subnets. So that's fairly easy, but it becomes more complex when you add the Azure Firewall, right? So if you're gonna go to the next slide, if you want to implement an Azure Firewall with your existing environment where you don't have an Azure Firewall, this can become a bit more complex, where you have to create a centralized VNet hub and then route all your traffic to that hub, and then also configure your Azure Firewall ruling to support those spokes. So that implementation can take some time, and of course have some issues in rolling out, whether you have default outbound enabled or not. Then those machines behind those posts gonna have some internet traffic denied, possibly. So this is a bit more complex to set up, and yeah, considering the timeline, it can take some time. So an Azure Firewall deployment itself already takes, I think, an hour or so. And then you can do your firewall, and then you have to do all your subnets. So yeah, it depends on your networking team, of course, but it can be done in a few hours.
Perfect. Yeah, and from an Aviatrix perspective, I mean, it's there's no re-architecture of your workloads. Yeah. There's no flow changes, so you're not now suddenly having to default route everything through a centralized inspection VNet. You have the spin up time essentially is how long does it take to spin up a VM, which again we all know is 5 minutes, maybe 6 minutes. Azure's a little slower, maybe 8, but having that spun up in your individual, VNet, then effectively turning on SNet, which is a single click from a centralized control plane. And again, even spinning up that VM itself can be done via the controller. So that's centralized as well. So you can do it across multiple VNets at the same time. And then enable a policy, and you have outbound access. So I would say in 10 to 15 minutes, you have your entire egress security filtering and NAT gateway configured globally from one solution. So the ease to set up is incredibly quick on Aviatrix, and which for that to actually blow out the cloud native solution is something really special. I think we might have
one thing maybe to add to that one, if I may.
Yeah.
So if you just go back to that slide again for a second, Dan.
Of course.
So everything you do via Aviatrix is also the idea of intent based. You tell the controller what your intent is, and the controller will do end tasks for you. So you never go to the marketplace and deploy an Aviatrix gateway VM. You never do that. You go to the Aviatrix controller and you say, I want NAT in this VNet, and I want to add a security policy to it. And in the background, the controller will make sure that the gateways are deployed in HA, that the route tables are appropriately configured, and stuff like that. So all the life cycle is handled by the controller. And the other thing that I don't think we mentioned is everything is also you can do everything via Terraform. So you can put it in your pipelines, automate everything as well.
Perfect. Thank you for adding that.
Yep.
So what are my options if I use vWAN, and can I implement Aviatrix with that? Do you want to cover that, Frey?
Mute button. Okay, so what are the options if I use vWAN, and how can I implement Aviatrix with that? So that's a good question. Can you go back to I think slide number 8, or I can do it, right? Let me see. 8. No. Oh, okay, perfect. Yeah. So this slide shows exactly that. So it really depends on what the requirement is. So basically, if you have the requirement to implement NAT or secure egress traffic, you can deploy this Aviatrix solution in parallel to vWAN. So vWAN is your hub where you're doing all of your east-west kind of routing, so between VNets or between on-premise and the cloud. And then the Aviatrix solution will be used, in this case, just for the egress traffic. So when your workloads need to go to the internet, and we add a security layer on top of that, also with the observability. Having said that, we can also use that same infrastructure to replace vWAN basically and introduce even more cost savings. But that's maybe for another future webinar that we can talk about that one.
Yeah, and I think there's a follow-up question for that same one that basically said, will Microsoft support us if we use Aviatrix versus the native components? Certainly, right? So this is all running on Azure native VMs. These are supported, resources, and again, from a lifecycle perspective, from a hygiene updates, all of that. Again, that's all completed through the controller itself. It's all automated, so that's not something that you have to worry about individually, I should say. And again, this is all on Azure native VMs. It's all known kind of traffic flows. It's not doing anything that breaks Azure in any way, shape, or form. So they're basically giving you the underlay for that, for your hosting environment. Aviatrix is just a overlay on top of that enables that connectivity, security, and observability that you guys have grown to know and love. So yes, you're still fully supported by Microsoft, regardless of the fact that you're using Aviatrix on top of it. And I think that is it for the questions. Just want to say thank you all for all of our attendees, and for anybody watching this after the fact. Enjoy this good session about the changes coming up with Azure. And I really want to say, huge shout out to our great partners at CloudNation. Don and Mark, you guys are phenomenal. Frey, always great to present with you, and appreciate all your time. And thanks all for joining.
Thanks, Dan.
Yes, thanks for having us.
Everybody.